Today is module 6, that's data link layer. If you remember, day before yesterday, we talked about the physical layer. So these are the OSI model. We'll discuss them one by one. Day before yesterday, we talked about the physical layer, right? And today we are going to talk about the data link layer.
Oh, no. I don't know.
So can you mute yourself now? Yeah, can you mute yourself?
Okay.
Hello? Okay. So we will talk about the OSI layer one by one. We have already discussed about the physical layer. Today we're going to talk about the data link layer. Okay. So these are the topics you will see. The purpose of the data link layer, the topologies, and the data link frames. What is the purpose of the data link layer? Guys, I think this is another very important thing. I think we will also do more effort on the OSI model. It's very, very important. Each of the layers has a very significant importance, especially the first three, the network, the data link, the physical, the data link layer, and the network layer. They're very, very important. We need to know their functions very well, and all the protocols that reside on each function and each hardware, where does it belong to, whether it's a physical layer device, or it's a data link layer device, or it's a network layer device. Because sometimes you'll be talking, they'll tell you this is a layer 2 device, this is a layer 3 device. So you need to identify all that. So the function of the data link layer is responsible for communication between the two network interface cards of the devices. Okay? The function is responsible for communication between the network interface card of your computer and the computer you're talking. Okay? It also allows the upper layer, such as the network layer, to have access to the physical layer. The data link layer sits between the upper layers and the physical layer. Devices at the physical layer are the cables, your wireless, and your fiber cables. They are all a physical layer device. So the data link layer is between the upper layer, such as the network layer, and the physical layer. And one more important thing is the data link layer also does error detection. It does not do error correction, no, but it will do error detection for you. How does it detect that error? Is using a frame check sequence called FCS, a frame check sequence, or CRC, cyclical redundancy check. We will see all this in more details. What it does is it performs a certain calculation on the data that you are sending and record that value at the bottom of the frame. So the receiving host will also do the same calculation and compare its value with the value of the sending machine. If the values are the same, then the frame is correct. But if the values differ, that means that frame is corrupt. So it's going to drop it, it's going to reject it. So you see all this in more detail, but the data link layer will do error detection, but not error correction. So this is the data link layer here. You can see we have the physical layer, data link, and the network layer. So the data link layer is between the network layer and the physical layer, guys. You have to look at all this. So the data link layer is divided into two sub layers. First one is the logical link control sub layer, LLC. Logical link control sublayer, and MAC, MAC sublayer. Okay, the LLC sublayer communicates between the networking software at the upper layer and the device hardware at the lower layer. So the LLC will communicate with the networking software at the upper layer, such as the network layer, and the device hardware at the lower layer, at the physical layer. So the MAC sublayer is responsible for encapsulation and media access control. Guys, you see, if you look at these two sublayers, this one faces the upper part and this one faces the bottom part. So this MAC layer is responsible for data encapsulation and media access. That is how will that information, how will the information be passed on to the media? Whether it's a fiber media or it's a copper media or it's a wireless media. So the MAC layer is the MAC sublayer is responsible for how the media is going to be accessed. Okay. So providing access to the media, how do you provide access? Packets exchange between nodes may experience numerous data link layer and media transmission. When packets are exchanged, along the path, you encounter different types of medias and different types of devices in between. Let's say you sit in Banjul here, you want to access Facebook. The Facebook server is in the US. Before your traffic reaches the Facebook server, you expect to encounter different types of medias along the line. So these different types of media, there will be a lot of encapsulation and de-encapsulation. This encapsulation and de-encapsulation, we'll talk about it a lot of times, but it's also very, very interesting. What I will need to do is maybe to do a demo on how these packets travel, what is the entire encapsulation process and the de-encapsulation process. De-encapsulation is the reverse of encapsulation. So a lot of things will happen in between. So we have to see each of them, what happened at the network layer, what are the encapsulation, because at the network layer, the source and the destination IP address is added to the packet. And at the network layer, the protocol data unit is called packet. So the protocol data unit at each layer has a name. You need to know that. So at the network layer, the protocol data unit is called packet. But when you get to layer 2, the data link layer, the protocol data unit is called frames. You understand? Frames. At that data link layer, we add the source and destination MAC address. So when the protocol data unit moves to the physical layer, that's the final layer, the PDU is called bits, because at that time it is turned into bits, ones and zeros, or electrical pulses. So these are standards or bodies that are responsible for the manufacturing or the standardization of data link layer devices. The IEEE, the International Telecommunication Union, and the International Organization for Standardization, and the American National Standard Institute. So now we move on to topologies. There are two main types of topologies. You have the physical topology and the logical topology. There are two main types of topology. You have the physical topology and the logical topology. What is a topology? A topology is simply an arrangement or the interconnection between devices. That's just a topology. An arrangement, how do you position your physical layer, physical devices, and how do they interconnect? That is called a topology. So there are two main types of topologies. That's the physical topology and the logical topology. The physical topology is the physical connection and how devices are interconnected. How do you run your cables physically between devices is called the physical topology. The logical topology is the virtual connection and the IP addressing scheme. That is it. The virtual connection and the IP addressing schemes of the devices. That's the logical topology. We move on to WAN topologies. There are three different types of WAN topologies we talk about here. First is the point-to-point topology. First is the point-to-point, hub and spoke and mesh topology. Okay? So the simple form of a point-to-point topology, it consists of a permanent link between two endpoints, a permanent link between two endpoints. That is called a point-to-point topology. An example of a point-to-point topology right now will be, okay, if you look at GRTS network right now, they have a router at their premises that is connected on a fiber to Serakunda Exchange just by the post office. So that is an example of a point-to-point topology. Point-to-point. You have a router at the Gamtel Exchange, you have another router at GRT's office, so they are interconnected using a fiber or any transmission medium. That is called a point-to-point, one-to-one. When you move to hub and spoke technology, hub and spoke topology is like one point to multiple points. We will give this type of example to banking scenario. Let's say FIB Bank has their head office at Kairaba Avenue. They have a branch in Brikama. They have one in Latrikunda. They have one in Banjul. So they want to interconnect all these branches to their head office. That is called a hub and spoke topology. Okay? Connecting all the branch sites to the head office is called a hub and spoke topology. So where we have a mesh topology provides high availability. High availability in the sense that you want to minimize downtime or eliminate downtime, so that if there is failure in one link, traffic is going to be rerouted to another link with a very minimal downtime. So that is called mesh. I think we will see them individually. You can see this is an example of point to point. Like I told you, you have one router, probably at Gamtel, that is connected to this GRTS router. So it is a one-to-one. It's called a point-to-point topology. Then we have different types of LAN topologies. We have the bus, the star, the mesh, and a host of them, you know. So these are the different types of LAN topology. You have the star topology, where you, in most cases, we see the star topology, where you have a centralized switch and run all your cables from end devices to the switch. That is called a star topology. Okay? You have the bus topology, where you have a central core and you connect all your devices to it. Then you have the mesh topology. That's another topology where you have interconnection to cater for redundancy. But you can see there is also a ring topology here. This is an example of a ring topology, where you have a ring of backbone network and you connect all your devices to the ring. So you also have an extended star, where you have two stars. You interconnect the two stars with a trunk cable. Guys, if you have any issues, please, you can stop me. I know I'm moving very fast. Huh? Hello, guys.
Yes, hello.
Okay, I said I know I'm moving very fast. Huh?
Yeah, but it's okay.
All right.
My only problem is the network. It looks it's only when you left one slash that I will reach to that. That's okay. I can understand.
Oh my God.
It's the network, yeah.
We have the duplex communication, the different types of communication. You have half duplex communication and full duplex communication. In essence, half duplex communication is a communication that happens one at a time. It's a communication that happens one at a time. Like the two parties that are communication will have to communicate one at a time. That is called half duplex. That means both parties cannot talk simultaneously. One have to talk and then wait for another person to talk the next time. That example of this type of communication is our radio. We used to call them walkie-talkies. That's an example of a half duplex communication. Then the next one is full duplex communication. This is communication that is bidirectional and it can happen simultaneously. Okay. An example of a device on this full duplex is an Ethernet switch. In an Ethernet switch, all computers connected in an Ethernet switch can send and receive at the same time. But if you look at the legacy hub, because people don't normally use this hub technology now, but the legacy hub is using half duplex. Two computers connected in that network cannot send and receive at the same time. They have to wait for each other. If they both want to send and receive at the same time, a collision is going to happen in the network. Okay? So we also now talk about the access method. What are the different types of access methods in the network? How do devices access the transmission medium to send their information? Because before a device can send, signals or whatever information, they must have access to the transmission medium, whether it's a wireless transmission or it's a copper or fiber transmission. So there are different types of access methods. Okay, so you have one called CSMA/CD, that is carrier sense multiple access with collision detection. And the second one is CSMA/CA, that is carrier sense multiple access with collision avoidance. These are the two main types of access methods. We will look at them, okay? So the CSMA/CD, that is the collision detection. The collision detection, it operates in half duplex mode, where only one device can send or receive at a time. So that is why it is using collision detection. It normally detects collision. So only one device can send or receive. They cannot send and receive at the same time. It uses collision detection process to govern which device can send and which device cannot send. So in this type of scenario, If a device wants to send, let's say in a network where you have 10 computers connected, and it is using half duplex mode, that is CD. If a device wants to send, before the device will send, first thing the device will do is the device will have to listen to the transmission medium, whether there is any signal transmitted, whether anybody is using it, whether the medium is free or not. If the medium is busy, the device is going to hold on. It is not going to send. It will only be listening to the medium. If there is no signal, that means there is nobody transmitting. That is the time the device is going to send. But if it happens that two devices set at the same time and their packets will collide, that means there will be an accident. They will collide in the network and they will all backtrack and wait for a random period to see if the medium is going to be free. But in a collision avoidance, devices send randomly and they can retransmit. Okay? Because there is the next one, that is the collision avoidance. The devices can transmit at the same time, in a shared medium. So we move to data link frame. How does a data link frame look like, guys? I'll still remind you about the OSI model. It's very important. You need to know the frame at each layer. How does a network layer frame look like? And how does a data link frame look like? You see them. Data link frame, like I told you, the protocol data unit at the layer 2 is called frame. That's why we have now, you can see it is called data link frame. So I don't expect you to call it a packet. Can I call you back? I'm in class. Okay. Sorry guys for that. So I don't expect you to call the protocol data unit at layer 2 as a packet. No, it is called a frame. So when you use these terms and you're communicating with somebody, the guy will know that you understand what you do. You don't have to mix things. Time is running. But this is how the frame is going to look like. First, the frame is going to have a head, and it's going to have a middle one is going to be the data, and it's going to have a tail end. These are the three components: head, data, and the tail end. You look at it, what happened? In the head, you are going to have 3 or 4 things in the head. The head is going to contain the start of the frame, the addressing. Remember, the addressing is going to be what? The source and destination MAC address. And it's also going to have the type, that is what type of layer 3 protocol is there. And it's going to have a control. The control is going to control the flow sequence. So in the middle, you have the data. And the tail end, like I told you guys, it also does error detection. So that error detection is going to be at the tail and the stop of the frame. But you see all this in detail. So this is how the frame look like. You have the head, the data, and the trailer. The head contains the addressing information, okay? And the data is going to be there, the information you are sending. The trailer has what? Error detection and the stop frame. So you can see, and the layer 2, we have the source NIC or source MAC address and the destination. And in addition to that, we have source IP and the destination IP for layer 3. So WAN and LAN frames. These are the different types of protocols that are used in LAN and WAN frames. If you look at this, Ethernet is a LAN protocol. The 802.11 is a wireless protocol. Point-to-point is a WAN protocol. We talk about point-to-point. Point-to-point is a WAN protocol. High-level data link control, that is HDLC, is also a WAN protocol. Frame relay is also another type of WAN protocol. Each protocol performs media access control for specific logical topology. So you will see all this in more detail before we finish this course. We'll talk about point-to-point, we'll talk about HDLC and frame relay. So that is the end of today's slide. This is the entire slides for data link layer, okay? So if you have any questions, queries,